Good morning, students. Today we are going to learn about hydraulic turbine. So, in the main objective of this lecture 1 are introduction to hydraulic machine, general layout of hydroelectric power plant, turbines, classification of turbines, efficiency of turbine. So, what is a hydraulic machine? Hydraulic machines are defined as those machines which convert hydraulic energy into mechanical energy, which is further converted into electrical energy. What is a turbine? The hydraulic machine which convert hydraulic energy into mechanical energy are known as turbines. Turbine mainly consists of Dalton, Francis, Kaplan turbines. So you can see the layout of a Dalton turbine. So these are the blades of the turbine. This is the runner of the turbine. This is the penstock through which water is coming. This is the nozzle, and this is a hand wheel and a spear. So if we are rotating the hand wheel, we can control the rate of flow water which is flowing through the nozzle, and through this jet of water is striking the plates of the turbine, and which is making this turbine to move. So these are the buckets you can see of the turbine. This is the casing in which the turbine is kept. So this is the general layout of a Pelton turbine. Next we can see general layout of a hydroelectric power plant. So in this video you can see how the water is stored in the dam and then it is allowed to flow through a pipe. This pipe is known as a penstock. This penstock carries the water down the turbine, and water moves the wheels of the turbine, which is at the lower level. So it is making the turbine move. As the water pressure increases as it moves down from the penstock, it drives the turbine, and this turbine is connected to the generator, and inside the generator rotor is spun by the turbine. So you can see the electricity is then stepped at with higher voltage using transformer, and it is distributed through the transformer lines, transmission lines. So you can see here once again how the water is flowing down, moving the turbine, which is connected to the generator, and how the generator is producing electricity, and it is further distributing through the transmission line. So this is the general layout of a hydroelectric plant. Next we will see some important terms related to your hydroelectric power plant. First is the gross head. What is a gross head? This total head is known as a gross head, or it is the difference between head race and tail race. This is the head race and this is the tail race. Okay. Next is your net head. So net head is equal to what? Hg minus hf. So Hg is your gross head, hf is the head loss due to friction. So you can, hf is here f 4fl v square d into 2g. L is the length of the penstock, v is the velocity of the penstock, and d is the diameter of the penstock. So net head is the effective head, also known as effective head, and is the difference between your Hg minus Hf. Next we will see classification of turbine. According to the energy at the inlet, we have impulse and reaction turbine. Next, according to the direction of flow through the, we have tangential flow turbine, radial flow turbine, axial flow turbine, mixed flow turbine. Next, according to the head at the inlet of turbine, we have high head turbine, medium head turbine, low head turbine. Next, according to specific speed of turbine, we have low specific of turbine, medium specific speed of turbine, and high specific speed of turbine. Next, according to the type of energy at inlet, we have impulse and reaction. So what is impulse turbine? If the energy available at the inlet is only your kinetic energy. So at the inlet of the turbine, if we have only kinetic energy, it is known as impulse turbine. And if there is kinetic energy as well pressure energy at the inlet of turbine, it is known as reaction turbine. Example of impulse turbine is Bristol turbine. Example of reaction turbine is Kepler turbine. Next, according to the direction of flow through the runner, first we have tangential flow turbine. If the water flows along the tangent of the runner, then it is known as tangential flow turbine. So when the water flows tangent in the tangent direction to the runner, it is known as tangential flow turbine. Next is the radial flow turbine. If the water is in radial direction through the runner, the turbine is called radial flow turbine. If the water at outward flows outward to inward radial, turbine is called inward flow radial turbine. And if the water flows inward to outward, the turbine is called outward radial flow turbine. Next is our axial flow turbine. If the water flows through along the direction parallel to the axis of rotation of the runner, the turbine is called axial flow turbine. And if the water flows the runner in radial direction but leaves in parallel direction to the axis of rotation, the turbine is known as mixed flow turbine. Next we will see efficiencies of turbine. First is hydraulic efficiency. It is the ratio of runner power by water power. So it is defined as the ratio of power given by water to runner of the turbine to power supplied by the water at the inlet of turbine. So runner power divided by water power. Next is our mechanical efficiency. What is mechanical efficiency? It is defined as the shaft power by runner power. So it is defined as the ratio of power available at the shaft of the turbine to the power delivered to the runner. So shaft power by water power. Power at the shaft of turbine divided by power delivered by the water to the runner. Next is volumetric efficiency. So it is defined as the ratio of water actually striking the runner divided by water supplied to the turbine. So it is defined as the ratio of volume of water actually striking the runner to the volume of water supplied to the turbine. Next is our overall efficiency. It is defined as the ratio of power available at the shaft to the power supplied by the water at the inlet of turbine. So it is known as the shaft power by water power. So once again we are writing this like shaft power by shaft power into runner power by runner power. Just we are changing the position of runner power here like this. Runner power we are writing here and we are taking this water power this right. So what this becomes our mechanical efficiency and this becomes our hydraulic efficiency. So overall efficiency can also be written as product of mechanical efficiency into hydraulic efficiency. So this is all about turbine and efficiencies. Thank you all students.